15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on this, the Space Nuts podcast. It's all about space, astronomy and stuff, space science, you name it, we do it. And my name is Andrew Dunkley, by the way, your host. And joining me as always is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hey, Andrew. How's it going?
Pollen City round here. Pollen City.
Yeah, it's that time of year again.
It's the worst hay fever I've ever had.
Oh, really?
And yes, I don't think I've ever had it worse than I'm medicated to the eyeballs, but it's the eyeballs that are suffering the most because the drops just don't do the trick. Yep. I mean, I love the change of season. I prefer the warmer weather, but yeah, it comes with a price. But we're right in the midst of it. But the reason is because we've had drought-breaking rains, and I know it's not official yet, but the drought is basically over in this part of the world. And we have got crops as far as the eye can see, way down south, all the way to the Hunter coast and right up in the northwest of the state around places like Walgett and Burke. There's just mega crops. The farms are just brimming with crops. It looks fantastic, and the canola's blooming. So you've got these sort of green patches with these yellow squares in the middle of them. They look fantastic. It really looks pretty. But the pollen, good grief! You can look out over the horizon, and it looks like a fog, but it's not. It's that nasty pollen stuff that gets into your system. But I think most people are pretty happy with the situation at the moment, and the dam's filling up. So we're all good. What about your part of the world, Fred?
It's not like that. I traditionally suffer from hay fever as well, but so far it's just been the odd sneeze down here in Sydney. But something to look out for, Andrew, if you have a lot of pollen in your atmosphere, you should check out the sun. And so what you need to do is put your thumb up, or better still, something a little bit bigger that blocks out the direct light of the sun. And you might find you see some coloured rings around it, which is called a pollen corona. And it comes about because if there's a lot of pollen in the atmosphere, the pollen grains are all the same size, and so you get a process called diffraction, which splits the light up into its rainbow colours. So you might see these coloured rings with reds and greens in them, which are quite spectacular. When I used to live in Coonabarabran, quite commonly at this time of the year, you could see them. They're well worth a look if you actually do see them. So you can let me know next time if you find.
I'll give that a crack because it is a clear sunny day today, but I can see a haze, so there is pollen in the air. So I'll give that a try, and if I can get a photo, I'll
even better.
Publish it.
Yep.
On our Facebook page. Yeah. Now today, Fred, we're going to look at. I was amused last weekend. I always read the news on a Sunday morning, just kick back with a cup of coffee and catch up on all the dross that's getting put out by those most savoury news outlets. And apparently, we were going to get hit by an asteroid again. That seems to be one of the Sunday go-to stories. We're going to get hit by an asteroid. Although this turned into a rather interesting story because it probably isn't an asteroid. It could be a rocket.
Yes.
So we will look at that. And we've got a bit of audio to play for you today. A piece of music has been put together, and it's titled The Music of the Milky Way. So we're going to hear that today. And something a little bit different in the question department because surprisingly, we were a bit light on for questions. Didn't get any new audio questions and only, I think, one email with 3 questions on it. So we're going to go with that. And I'd like to say that this fellow works for the Jet Propulsion Lab in NASA or, for JAXA or one of, I don't know where he comes from, but his name's Asley, and he's come up with 3 rather stunning questions that we're going to put to you, Fred, because, they're worth answering and they're worth discussing. So we don't often play favourites, but Ashley came to the party for us this week with 3 stunners, so we're going to knock them all over in this week's edition of Space Nuts. Now, Fred, fake news. We're going to get hit by a not asteroid. In fact, I don't even think we're going to get hit by it, but we might capture it.
That's a possibility. That's certainly the kind of thing that has been raised before with such events as are now taking place. So what has happened here is that what was classified as an asteroid has been detected, I think, by the Pan-STARRS project, which is a telescope on a mountain called Haleakala in the island of Maui in the Hawaiian chain. Haleakala has a number of telescopes. It's not quite as high at 10,000 feet as Mauna Kea on the big island of Hawaii, which is over 14,000 feet, but still has absolutely stunning conditions for observation. And I'm pretty sure that's where this was picked up. So an asteroid in a very similar orbit to the Earth around the Sun, gets classified as an asteroid, given a name, 2020 SO. But what has now transpired is that a gentleman by the name of Paul, it's either Chodas or Kodas, Chodas, he is the director of the Near-Earth asteroid section at the Jet Propulsion Laboratory, Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory in Southern California, Pasadena, in fact. So Paul has, Dr. Chodas, let's give him his formal name, I hope I'm pronouncing it right, actually looked at the orbital dynamics of this object and finds that it is in an orbit that may reveal the fact that actually it's not a natural asteroid at all. It is the spent upper stage of a rocket, in fact, a Centaur upper stage, very commonly used during the 1960s, a rocket which was taking a spacecraft to the moon, not a spacecraft with a crew on board, but one of the Surveyor series of robotic spacecraft, in fact, Surveyor 2, which was on its way in 1966, but it didn't make it because there was a fault with one of the thrusters, I think when the Surveyor was coming down to the moon, and it actually crash landed on the moon. Surveyors are well known to, people who are interested in our exploration of the moon, because Surveyor 3, which was successful and went the following year, 1967, was actually the one that was landed right beside by Apollo 12, so that the astronauts of Apollo 12 could pull bits off it and bring them back to see what a year and a half of exposure to the lunar climate did to things. So the Surveyor series were generally successful, but Surveyor 2 wasn't, and its upper rocket body would have basically gone into orbit around the sun. And that is what this scientist thinks has now been rediscovered. So,
okay, now this is a bit unexpected because when it passed the moon, they basically thought, well, that's the end of that. We'll never see this thing again. And it may, and this has not been confirmed yet, has it? It's just a theory at this stage, but the numbers are starting to add up. But they didn't think it'd come back. It's like the old cat, isn't it? Just keeps turning up.
It keeps turning up, that's right. These things do. Once again, we're littering the solar system. So why do you think it's this particular object? Well, it's basically an orbit that is really very nearly circular, very similar to the Earth's, in the same plane as the Earth's. There's no tilt, and that is the kind of smoking gun, and actually slow as well, 2,400 kilometers per hour. If my arithmetic done in my head is correct, that is 2/3 of a kilometer per second, which is very slow for an orbiting object. And what will confirm it, Andrew, is what the effect of solar radiation is on it, because this is the Centaur is, I mean, it's an empty a tin can, really, an empty large one.
That's how it's been described in the popular press, as an empty tin can. Yeah. David Bowie would be thrilled.
It would, that's right. 8 meters long, 3 meters in diameter. So it's very light, and that means that the sun's radiation could have an effect on it, could sort of push it into an orbit that is what we say perturbed by non-gravitational forces. In other words, its orbit could be changing because of the radiation of the sun, and that would probably be the clincher. The thinking is that it's going to go into orbit around the Earth, but that orbit will be unstable. It'll probably spend 4 months or so circling the Earth from about the middle of next month, mid-November, and then will be ejected back into its own orbit around the sun, and that might be the last we see of it. A really interesting piece of detective work on the part of scientists whose day-to-day job is actually looking at these things.
Yes, indeed, and the fact that it's sort of been doing this for 54 years.
Yeah, that's right.
It's been sort of gallivanting around. And is it possible that it's been around Earth before and we haven't noticed, or is this maybe its first comeback?
Yeah, I think that's right. I think there's a possibility that it may once have, in the past have been in orbit around the Earth. But it's now, because we've got these really powerful near-Earth asteroid searching telescopes, that we find these things. And you can bet your life that when the Vera C. Rubin telescope comes on stream, I think next year, which is an 8.4 meter telescope, which will survey the entire sky every week, we'll find a lot more of this kind of thing.
Yeah, unfortunately, there is a lot of garbage out there that we've just sort of left.
Yeah,
I think in the modern age we're starting to pay a bit more attention to it and make things more retrievable and salvageable. But 50 years of not doing that has created all sorts of junk. Do we know what Surveyor 2 was supposed to achieve?
It was a lander. The idea was very much to make sure, first of all, that you're not going to land on the moon and sink into its surface because of this dry quicksand effect that some people thought that the moon might exhibit. It was a big worry, especially when you're planning to send humans to the moon. But also it had all the usual radiometers, spectrometers, a camera on board, stuff to really sample the lunar environment in as much detail as possible.
Now, it is possible that this is not the rocket we're talking about, but it is starting to look more and more likely. I suppose that's the best way to put it.
That is very much the conservative approach to take, Andrew. I admire your scientific insight there. It is probably it, but we're not certain.
It's called journalistic integrity, Fred. Not many of us left.
Well, you're the last person I would have thought of. No. Just joking. Just joking.
Okay, fair enough. There may be more on this story, but it won't come from me. You're listening to Space Nuts with Andrew Dunkley and Fred Watson. This episode of Space Nuts is brought to you by LastPass, simplifying your online life. Now, if you're anything like me, you probably find one of your biggest frustrations in life is remembering all your passwords, all those login details, usernames, passwords, important information that have built up over many, many years. And you might have hundreds of them. I know last time I counted, I had like 88 passwords for various things, and it can get quite cumbersome. So what can you do about it? Well, I use LastPass. It's a password manager. It's a fabulous solution to this problem. And believe me, the relief is unbelievable, not to mention time saving. Now, you can sign up for LastPass and you'll be joining 25.6 million fellow users from around the world and 70,000 plus businesses. With those kinds of numbers, they've got to be doing something right, and they do. In my experience, it has simplified everything. I've got every username, every password from everything I do built into LastPass, and it's integrated. I can use it on my desktop, I can use it on my laptop, I can use it on my phone, I can use it on my iPad. It's that simple. And it can even work in a way whereby you don't have to type in anything. You open LastPass, you type in what you're looking for, let's say it's your Gmail account or something, and it will bring it up, and you just click on the link and it will open it for you. You don't have to do anything. It is really, really good. Now, you can get the premium package for around $4.50 a month, and there's a family and enterprise plan as well, and it works, as I said, across all devices. Put your passwords in, you can go into autopilot, you can reduce the stress. It's really fabulous. I highly recommend it, and it will give you peace of mind. You will never have to sit there going, oh no, I've forgotten my password. It's one of the worst feelings in the world, and this is the solution. It's really simple and highly secure. I mean, it is very safe. All you have to remember is a master password, one password, so that you don't have to remember any of the others. So check it out. Go to spacenutspodcast.com/LastPass and help support the show. Sign up and you can check it out for free at spacenutspodcast.com/LastPass and just simplify your life. Link details are in the show notes and on our website. Now, back to Space Nuts.
Space Nuts.
Now, don't forget, if you are a social media user, you can find Space Nuts on most social media platforms. There's a presence on Pinterest, as far as I'm aware, certainly on Twitter, definitely on Facebook. And there's a podcast group that's been created by Space Nuts listeners. It's called the Space Nuts Podcast Group. They put a lot of thought into that name. I think there were several votes before they decided upon that one. It's where Space Nuts listeners can get together and talk to each other. Quite often questions get posed and answers are very liberal in the way they're furnished. People love talking to each other about these things, whatever the topic might be. So check it out if you haven't joined the Space Nuts podcast group yet. I highly recommend it. I poke my head in there occasionally and occasionally make a remark, but it's really for the listeners. They're the ones who wanted to put it together. So that's where you go. Of course, the Space Nuts official Facebook page is there as well, and you can join that too. And of course, YouTube. You can listen on YouTube and find us there, and I don't know where else. So many other places. Now, Fred, let's go to this next story, which is something a little bit different for us because it's about listening to the music of the Milky Way, as reported by the astronomy.now.com website. We should give them a credit because they've put up this piece of audio. This is really, really interesting. What sort of led to this? Do we know?
I think it's come about because people, know that there are many different ways of looking at the universe. And so this is a novel and new and different way that has been put together by scientists at the Chandra X-ray Observatory. And in fact, it's, Astronomy Now has carried the story, but the Chandra X-ray Observatory website has information on this. So basically, Chandra is NASA's flagship mission for X-ray astronomy. It's a bit like the Hubble. It's one of the great orbiting observatories. And these scientists at Chandra, what they've done is they've said, well, we've got images of the Milky Way taken by all these marvelous orbiting telescopes, and that gives us a very multi-wave band view of the Milky Way. And so what they've done is they've merged images from the Hubble telescope, so that's in the visible and ultraviolet, from the Chandra X-ray Observatory, so that's X-ray images of the Milky Way, and the Spitzer Space Telescope, which is no longer operational, but did actually observe the Milky Way in the infrared wave band. So taking these four really, because you've got ultraviolet in there as well from Hubble, very, very different wave bands, and made a composite image of the Milky Way, and then they have sonified it. And the sonification process says, okay, let's look at the picture, and from top to bottom, imagine that you're going from higher to lower notes. So that gives you, if you get a ping in the middle range of the musical scale, then that's somewhere in the middle of the image. And a ping would be caused by a point of light. A drone would be caused by an extended object, something which covers many, many pixels. In other words, a bigger part of the image. And then they give it a tone, which depends on the instrument which was used to make that particular part of the image. In other words, the Hubble or the Chandra or the Spitzer telescope, they've given it a kind of timbre, a characterization of the note. And so when you put it all together, you get something that I think is extremely beautiful, a kind of sonic journey across the length of the Milky Way. Remember, the high notes are from the top of the image, the low notes are from the bottom of the image, but they're played as you scan across the width of the image, and get a very restful sound. It's sort of
it's lovely. It is really lovely, and it's so. What we're about to hear is actually scientifically produced. This isn't just somebody playing games with noise and just sort of running them across a 400 light year wide image. This is scientifically produced. So what you're hearing is designated sounds based on the objects in the image. Is that what?
Yeah, that's right.
That describe it?
Perfectly, and in a way, it's a different way of looking at the sky. Except you're not looking, you're listening to it. But if we were equipped only with ears, and some people are, then this is a great way to visualize the splendor of the Milky Way.
Okay, well, without further ado, let's have a listen to the music of the Milky Way. It's absolutely lovely, isn't it?
Gorgeous.
And to think that that compilation is based on the visual overlapping of several observations and put together to create that sound. One of the sounds you heard, and I don't know which one it was, but I'm guessing it was one of the big ones, was Sagittarius A star,
That's right.
which we've talked about many times. And several other objects in our particular part of the universe, the Milky Way. So, that's just beautiful. They've done a really good job of that, haven't they?
That's right. Who would have thought a black hole would have sounded so lovely? Because in the middle of Sagittarius A star, that's where the black hole is. And just a postscript to this, Andrew, if people want to follow up a bit on this, the Chandra X-ray Observatory website, which is chandra.si.edu. If you go to that website and hunt around a bit, it's actually under their photo album section. You can find the sonification. You'll find exactly what we've just been playing, but you can also find the individual tracks that come from each of these different telescopes. So You can find the Chandra track, the Hubble track, and I think the Spitzer track as well. You can listen to them independently. And you can also look at some other objects in the sky. They've sonified an image of Cassiopeia A, which is a very bright X-ray source in the sky with an optical counterpart. And perhaps most especially, they've sonified the pillars of creation. Remember the images from the Hubble Space Telescope, those 3 pillars of creation. They've done a sonification of that too. So you can look at all of this, and it's a great place to have a look around, especially if you like music and you're musically minded. A different way of looking at the sky.
Yeah, this could be really good for the sight impaired.
Exactly.
The people who never get an opportunity to see what's out there.
Yeah, exactly.
Creating images in their mind through music or through various tones might be an option. I think it's fabulous. Yeah. We might pop that on again towards the end of this episode. It's not unlike the way we record our podcast, Fred. There's the Fred Star sound on one side and the Andrew Black Hole sound on the other side, and we put it all together at the end. Our tracks are independently recorded from different observations.
Yeah, doesn't sound as good as that, though, does it?
No, definitely not. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Space Nuts.
As always, I'd like to thank our patrons, the people that put a little bit of coin into the podcast via Patreon or Supercast or Acast, whatever is your preference. All the details on our website, of course, spacenutspodcast.com if you'd like to become a patron. And if you are a patron, keep an eye out for new material. It should be up very, very soon, if not already. A couple of new segments for our patrons. Of course, as a patron, you do get bonus material, you do get the ad-free version, and you do get the early edition of the Space Nuts podcast. That's just part of the deal, and our way of saying thank you for supporting us. Every dollar counts, and it keeps us sort of hooning along in space, as we like to do. Now, Fred, question time, and we have 3 questions to tackle today. 2 are pretty serious topics. One's just a bit tongue-in-cheek, but it should be fun. And they all come from Asley. Now, Asley has sent us questions before, but for some strange reason, we've hit a bit of a question drought. So don't forget, if you want to send us a question, you can do that via our website. Just fill in the blanks at spacenutspodcast.com, or you can go to the AMA tab at the top of the website, click on that, and actually record your question with your own voice and everything, and ask your question that way. Just tell us who you are, where you're from, and ask your question, like how did Andrew go at golf last weekend? Yeah, well, I shot 81. That was pretty good, yeah.
Was that 81 light years?
81, well, we should have hit it that far. But yes, that's how you get your questions to us on Space Nuts. Now, thank you, Asley, for sending in this treasure trove of questions. Hi, Andrew and Fred. I have more questions for you. This first one is about population 3 stars. Is there a theoretical minimum size for population 3 stars? There is obviously a lower mass limit for younger stars before they are classed as brown dwarfs, which is about 10% the mass of our sun. But is this different for stars which would have no metals in their formation? This, of course, leads to the question, could there be population 3 red dwarfs with no metal in their spectra? So that's his first question, Fred. That's a really fascinating and insightful question. Obviously knows his stuff, does Asley?
Yeah, indeed. So let's just what they say. Let's just unpick this. Yes, that's what they say in journalistic circles. As you would know, what is a population 3 star? So this was a classification that goes back to a man called, I guess he would have been Walter Baade when he was in Germany, but he moved to America in the 1930s and became Walter Baade, a very famous astronomer who during the blackout, actually, at Mount Wilson Observatory, when Los Angeles was blacked out during the Second World War, he observed the stars of the Milky Way and classified them into what are called populations. So very briefly, population 1 is stars like the Sun, stars which are sort of rich in, now what we call metals is anything other than hydrogen and helium. So to an astronomer, oxygen is a metal, as is calcium, as is carbon. So stars are made of hydrogen, helium, and metals. It's a curious thing that has evolved over the decades. But what he said was that population 1 stars are rich in metals. They've got all the components that we find around us on the Earth, because that's where they've come from originally, from other stars. But then there's population 2, and he noted that they are stars principally in the central region of our galaxy, and also in the galaxy's halo, the spherical swarm of stars which surrounds our galaxy. And they are much lower in metallicity. That means they've got fewer of these heavier elements like oxygen and iron and carbon and all of that. But there's also this postulation of a third population, population 3, which is the very first stars that were created in the universe. And because metals, heavier elements, are created in stars, if you go back to the first generation of stars, you should find stars with no metals at all in them. And they haven't actually been found yet. We found population what we might call extreme population 2 stars that have got the minutest trace, and usually it's iron that you're looking for, but very little. And you know that they are very, very old stars because they've got such small amounts of these contaminants that have come from earlier generations of stars. But population 3 is still something we have not genuinely seen. And population 3 stars are usually assumed to be very large, with masses up to 100 times the mass of the Sun. Because they were formed in the early universe, hydrogen was everywhere. They pulled in, lots and lots of hydrogen as they collapsed gravitationally into a star. But there wasn't much else apart from the helium, which also comes from the Big Bang, by the way. So the hydrogen and helium are leftovers from the Big Bang. Okay, so to the question, is there a lower mass limit? And that's a really interesting question, because as I've just said, we normally think of these things as being highly massive. The outcome, and I'm not a specialist on population 3, although I've worked, to some extent with scientists who are looking for extreme population 2 stars. We did that in the RAVE survey. We actually looked at some very low metallicity stars, which are extreme population 2. But there certainly have been studies that have looked at exactly this. If you've got a low mass star being formed in the early universe, what would happen to it? And the usual thinking is that a low mass star wouldn't stay a low mass star for long, because as it was growing, there's so much raw material there, it just accumulates more gas and becomes a high mass star. So the thinking is that there probably aren't any, but there was a study which took place in 2017 that looked at the possibility of there being a low mass star, or a star which is going to be a low mass star. It's still accreting material. If, because of gravitational interactions with other objects within the cluster in which it's being born, if those gravitational attractions ejected it from the birth cluster before it could collect more mass, then you might have a population 3 star that survives to the present day. And they're looking at something about 0.8 of a solar mass. So it's not the brown dwarf sized objects that Asley was referring to, which are indeed, actually, they're smaller than 10%. I think it's 13 times the mass of Jupiter is the lower mass for a brown dwarf star. So they're not at that level. They're much more like the mass of the Sun, but 0.8 of the mass of the Sun. This was suggesting that a star of that mass could survive to the present day. And that means we might find one that was ejected from its birth cluster before it could get bigger. But it hasn't been found yet. The normal way of looking for population 3 stars, of course, and this is one of the targets of the forthcoming array of extremely large optical telescopes that we will have, that is to look into the distant universe. So you're seeing these stars as they were, just a few 100 million years after the birth of the universe. That's where you expect to find conclusive evidence of population 3 stars, of course, by looking at their spectra, by looking at the rainbow spectrum, which contains the signature of any metals that might be there, or hopefully in this case none, just hydrogen and helium.
Okay, so when he asks about population 3 red dwarf stars, again...
Probably not.
Mm.
Probably not quite that small. But, who knows? We might find something like that. It's a great question and a great suggestion. And population 3 stars are really interesting, as you can tell from my rather long-winded answer there.
Well, yeah, it's just another thing we think exists and we just haven't found yet.
Yeah,
there's a lot of that going on in
astronomy.
There's a lot of that.
Yeah, that's right.
Okay, now Ashley's second question is about the effect of dark matter. I just heard everybody groan. We talk about dark matter too often. We noticed dark matter's effect on the motion of stars in the galaxy on the large scale. Could we expect to find a similar effect on a smaller scale, like the orbits of the outer planets in our solar system? Would it be a feasible idea to put a high accuracy clock on a deep space probe like New Horizons to measure the gravitational field in outer solar systems, or our outer solar system in this case?
Yeah, so you're already measuring the gravitational field just by the trajectory of the spacecraft. That actually tells you what gravity is experiencing as you watch its movements over time, and so it's being tracked very accurately. And so the gravitational field is exactly what you'd expect, with a few what we've referred to already in this podcast, non-gravitational perturbations, where the radiation of the sun actually pushes things in a slightly different direction from what you'd expect from pure gravity. So that's all sort of taken account of, but you would not really expect to see any effects of dark matter in the solar system, because on the scale of the solar system, it's very likely that the distribution of dark matter is uniform. So it's just providing a uniform background within which the planets are orbiting and everything is going on as per normal. It's only when you look at larger scales where the dark matter seems to be concentrated, and in particular on the scale of a galaxy, we know that the dark matter is concentrated towards the center of the galaxy but extends in a spherical halo, and the galaxy is much, much bigger than the solar system. That's when you start seeing the effects of dark matter. And of course, when you look at bigger structures like clusters of galaxies, you will also see its effects there. So on the scale of the solar system, we're too small to see the effects of dark matter.
Okay. I would have thought, and you probably said this in a different way and much more insightfully than I did, but I would have thought that dark matter affects everything when you take into account the entire universe.
Yes, that's right. It does. But if you're immersed in a sea of dark matter, which is not changing at all, then you can't detect it, at least not from a gravitational point of view. You can detect it, we hope, one day by very subtle particle physics detectors, and there's a new one being built. Here in Australia called actually in a mine, the Stowell Deep Mine. They're putting a dark matter detector in there to look for these rare interactions that dark matter might have with normal matter. That's our best bet for finding it, I think, rather than looking at the gravitational changes on a small scale.
Mm-hmm. All right. Now let's get to the final question from our interrogator this week, Ashley. This one is more of a fun question to do with messaging extraterrestrial intelligence. If we take the premise that lots of technologically advanced civilizations exist in each galaxy, but they are separated too far in space and time for a response, then we can ask the theoretical question of the aliens, i.e. ourselves, what would you like to know that we can tell you? So flipping the question, so we're the receiver, what would you, both Andrew and Fred, like the aliens to tell us? A quick example of such a thing, we transmit a picture of the Andromeda Galaxy to the Andromeda Galaxy, notwithstanding the link budget issue. As the signal passes through the galaxy and various civilizations detect it, knowing that we are long gone, they decode the signal and see the completely useless but interesting information of what their galaxy looked like 2 million years ago from the Milky Way. Flipping that same logic, we detect the signal from Andromeda, and the information it contains is 2.5 million years old, a picture of our galaxy from their perspective. So what's Ashley actually asking us to answer on this one? He's asking us what we would like to tell aliens. Is that it?
No, what we want the aliens to tell us.
Oh, okay. I've got a feeling we've been down this road before.
Yeah, we've been down similar roads, but it's quite a nice question. And it actually introduces an interesting concept, messaging extraterrestrial intelligence, which is not something we've done in a big way. I mean, we do it inadvertently by all the radio signals that are leaking out into space from the Earth, and there's this shell of radio signals that's virtually 100 light years in radius, because that's how far these radio signals have gone. They're probably so weak now that they're indetectable. But we've never, I think there have been 2 occasions when testing new radio telescopes, messages have been beamed into space in directions that we know contain clusters of stars. One, I think, was with the Arecibo dish, and what was done was a kind of crude picture was encoded into the signal and it was beamed off. They are, however, very rare events, and there hasn't ever been a sustained campaign to send signals out directed into space at, for example, at stars that might contain, that might have Earth-like planets in orbit around them. That has not happened. But there is a project which is part of the breakthrough set of initiatives, which we've talked about before. This set of initiatives funded by Yuri Milner, a Russian billionaire, with a number of quite eminent scientists among his board, which included, certainly when he was alive, Stephen Hawking. Breakthrough Listen is one of them, actually using radio telescopes like Parkes to listen for extraterrestrial signals, none of which have been found yet. But there is something called Breakthrough Message. It's part of the Breakthrough Initiative. And as it says on their website, Breakthrough Message aims to encourage debate about how and what to communicate with possible intelligent beings beyond Earth. It takes the form of an international competition to create messages that could be read by an advanced civilization. The message must be in digital format and should be representative of humanity and planet Earth. But they make the note that for the moment, we have no plan to send these messages. It's really about encouraging global discussion on the ethical and philosophical issues of sending messages into space. And they pledge not to transmit any message until there's been a wide-ranging debate at high levels of science and politics on the risks and rewards of contacting advanced civilizations. Stephen Hawking, you might remember, was dead against this kind of thing because he thought that it might look too tasty for the aliens.
Well, there's always the risk of misinterpretation.
Yes, that's right. Exactly.
You could send a message of goodwill and humanity, and they interpret it as something quite hostile.
A declaration of war.
Yeah. Or it translates to, "Did you remember to bring the milk?"
Yes. Yeah, that's right.
And why would they want to know that? I think it's been well portrayed, and I know this is a bit of a joke, but this sort of situation has actually been well portrayed in The Hitchhiker's Guide to the Galaxy. Douglas Adams had a lot of fun with this misinterpretation of messages. And wrote some very funny parts to the story of The Hitchhiker's Guide to the Galaxy in his entire story, like the aliens that attacked Earth because they misinterpreted a message and got eaten by a dog.
They got the sign.
That man's brain still intrigues me.
Yeah, but the best portrayal was the movie Arrival, which I think you saw, where the whole of the movie was about the issue of how you communicate with these aliens who turned up on our doorstep. Very, very interesting, ideas in that movie. It was quite a nice movie.
And the other one that portrayed it well was Contact, where we received an alien signal, and what they were sending back to us was the opening ceremony of the 1936 Olympics. And the first image we saw from the aliens was a Nazi swastika. So, I mean, there it is. Yeah. There it is. Exactly the same issue. Misinterpretation, misunderstanding, miscommunication, whatever you want to call it. I suppose we should probably indulge Asley and say, what would we like the aliens to tell us? I think I've tried to think about something different. I mean, the God question comes up. How did you come into being? Why are you there? What's your history? Do you believe in a creator? I'd really like to go down that road with the aliens. I think it would be interesting to see if they sort of became advanced and intelligent beings and had a biblical belief backing it up, as we do on Earth in many different forms. But yes, that's something I would wonder about, and so I would ask that question.
And you could extend that, Andrew, to sort of ask them what their version of evolution was, because if you ask a scientist on Earth that same question, where did we come from? Then we've got a fairly cogent story about that, but of course it all has to have a universe there in the first place, and nobody's very sure about where that came from. So I think that is a great question. It's a great line of questioning to take. Mine would probably be a lot more, a lot simpler, and maybe a lot more naive, if I can put it that way. It'd be something along the lines of,
I know what you'd ask.
Go on then.
Do you have cats?
Do you have cats? Yeah. Do you have roosters? That's what we'd ask.
Do you have roosters?
Yeah. No, it would be actually exactly that. It would be, what's it like where you are? In other words, to use them as a probe as a tool to probe the details of an environment in space which is a long way from us. That would be very interesting. It would be like having a free telescope, a telescope that could give you imagery of things on a local level on an extrasolar planet somewhere. That would be priceless information. Dependency weather records, almost that sort of thing, which had led us probe their environment in a way that would be very informative to scientists here on Earth.
The truth, Asley, is you'd probably never stop thinking of questions to ask them.
Right.
As you got into it, there'd just be so much more that you'd want to know. It would be an ever-evolving communication situation, I imagine, which would, of course, end with, Fred, so long and thanks for all the fish.
Exactly. Yep.
No, but Asley, thank you. You have been our guest interrogator this week, and some really, really interesting topics that you've brought to the platform this week, and we appreciate it. Thank you so much. We're going to have to wrap it up. Oh, by the way, yes, if you do want to ask a question, as I mentioned before, you can do that on our website. Go to the AMA tab to record your question, or you can do it the old-fashioned way by sending us an email. All available on our website, spacenutspodcast.com. And that's going to wrap us up for another week, Fred.
It sounds like it, Andrew, but that's been a great discussion, and I look forward to the next one, which might not be too far away.
It probably won't be. I'm thinking a week or so. Thanks, Fred. We'll go out with some beautiful sounds. The music of the Milky Way, as created by the Chandra X-ray Observatory and the Spitzer Space Telescope and the Hubble Space Telescope, all those images put together to create a beautiful image, but then they put music to it and created this. It is just absolutely lovely. And that's how we'll finish this week. Thanks as always to Fred. Thanks to Huey in the studio. And from me, Andrew Dunkley, thanks for your company. We'll look forward to you joining you again on the next episode of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.